Hey everyone, welcome to how Wayfair is transforming customer experiences with data-centric AI. Seems like we have a packed room, so really excited to have everyone with us. Why don't we do some quick intros to get us started? So my name is Daniel. I am a PM lead. I help lead our enterprise infrastructure and computer vision efforts. In a previous life, I led anti-scraping teams at Meta to prevent data exfiltration at scale. For fun, I'm actually an avid spear fisherman and freediver. So if you really like to hold your breath and feel see what it feels like to drown. That's what I like to do for fun. But yeah, Kiran, how about yourself? Quick introduction on what you like to do for fun. Vinny, if you could, next slide, please.
Sure. Hi, everybody. I'm Kiran Kavanagh. I'm the principal architect for the Wayfair account here at Google Cloud. Been at Google a couple of years, was at Amazon and AT&T and other tech companies before that. What I like to do for fun, well, one of my main hobbies is a Brazilian martial art called capoeira. I admittedly have not been practicing a lot lately because things have been quite busy, but that's what I like to do when I do have some free time. Vinny?
Kieran, I have to say that was unexpected, but like very, very, very cool. That's awesome. Vinny, how about yourself?
Love that one. I'm Vinny DeGenova. I'm an associate director of machine learning here at Wayfair, where I lead our catalog understanding organization, which is a team of machine learning scientists and engineers that are focused on a few different problems, including catalog schema enrichment, user-generated content analysis, and foundation model development and deployment. And outside of work, I love snowboarding, and I'm currently learning the piano.
Dude, that's awesome, Vinny. Let's go snowboarding together sometime.
Love it.
Awesome. If you could, next slide. So at a super high level, here's our agenda for today. First off, I'm going to give a short and brief introduction into like what is Snorkel and how we think about data development. Kiran is then going to spend a little bit of time going through some of the Google Cloud AI innovations that enabled us to get where we are. And then finally, Vinny is going to spend the bulk of his time talking about the product cataloging use case that we all collaborated on. So with that in mind, let's get into Snorkel. Next slide, please. To get us started, what problem is Snorkel actually trying to solve? In our view, high quality data is required to deliver performant AI models at scale. By and large, enterprises have already collected large and specialized domain-specific data sets for a variety of use cases. The key bottleneck that the majority of data science teams actually face is actually productionizing that enterprise data into curated and accurate ground truth, which can then be used to train AI models. Unfortunately, AI development today, using traditional methods, is slow, manual, painful, and error-prone. So lots of manual work, lots of mistakes. Any change into the input data or label taxonomy means that you need to start from scratch. Next slide, Vinny. Snorkel Flow was essentially built to help enterprises solve this problem of iterative AI development. We enable user archetypes like subject matter experts, annotators, data scientists, to programmatically collaborate and annotate data at scale within the same platform, analyze and evaluate error slices when that data is noisy, incorrectly labeled, and finally iterate and train fine-tuned models with updated ground truth to get optimal performance. As a result, Snorkel can ingest your raw enterprise data and produce high-quality ground truth data sets far more efficiently than traditional manual methods. One final note, Snorkel is an enterprise-first product. Data security, governance, and IT administration is a core principle of our platform. What does this mean? You can choose to bring your data to be developed within Snorkel-hosted environments on cloud or Snorkel-managed VPC, or you can install Snorkel within your secure environment to be co-located next to your data, be it private cloud, on-prem, or air-gap environments. Snorkel is SOC 2 and HIPAA compliant, and we perform regular third-party penetration testing and continuous image scanning to ensure that Snorkel actively mitigates potential security threats. Cool. So that now you have a quick intro into Snorkel and a high-level understanding of the Snorkel platform. Next slide, Vinny. I'm really excited to give everyone a sneak peek into our new product launch in 2024, which we believe can help e-commerce retailers drastically improve their product search and discovery experience. This is Snorkel Computer Vision. Next slide. I don't want to steal Vinny's thunder later on in the presentation, so I'll be really, really brief. Snorkel now supports the ability for data scientists to leverage programmatic labeling to classify images at scale using foundation model in the loop workflows. Specifically within our data development studio, Snorkel enables data scientists to perform natural language semantic search and filtering over your product SKU images, or perform image similarity search across your data set. And finally, you can leverage the existing text-based workflows that you already know and love to incorporate additional relevant text metadata like product captions to enhance and improve the performance of your image annotation workflow. If you would like to see a demo and get access to the same programmatic annotation studio capabilities that Wayfair used to achieve their product catalog tagging results, please reach out to myself or Snorkel account representative. We'd be happy to set that up for you. Next slide, Vinny. Although, of course, we're excited to share our learnings and solutions with the broader market at large, a big part of any new product launch is to give thanks to our partners first. One of Snorkel's core values is practical innovation. It's a part of Snorkel's DNA that we work with design partners to build new products, because that's how we stay focused on solving real-world problems. Google was one of our first design partners in 2018 to 2019 and used early versions of Snorkel's core technology to solve complex content, product, and event classification problems. Our new image classification product features are actually a direct result of a year-long partnership with Wayfair and with Vinny, and you'll hear more about that from him shortly. But first, I'd like to have Kiran share a quick perspective, as our partnership with Google was key to ensuring that Wayfair's new AI services, co-developed with Snorkel, would seamlessly integrate with existing Google-centric AI workflows and could be productionized quickly. Kiran, the floor is yours.
Sure, thanks, Daniel. I'm really excited to participate in the webinar with you all today. And in today's webinar, we're really celebrating the collaboration and partnership among 3 different companies, as you mentioned, Daniel. And just we're all working together under the same unified set of goals. And to double click on how we are all working together, Snorkel is a valued partner of Google Cloud, and many Google Cloud customers are using Snorkel's products on our cloud. Also, Wayfair is a valued customer of ours. I'm fully dedicated to the Wayfair account, so I get to work with teams all across Wayfair every day who are building all kinds of interesting use cases. And with that in mind, one of the things, if we move to the next slide, one of the things that we will talk about is ML ops, and that will kind of form the foundation for a lot of what we'll be discussing today. And Wayfair's ML ops strategy involves empowering data scientists to focus on building world-class ML models and to be able to easily productionalize those models. And one of the things that we're proud and happy about on the Google side is that Wayfair is standardizing on Vertex AI as their ecosystem for training ML models, fine-tuning large language models, and pretty much everything in between, every step in the process of managing and deploying ML models. And I won't walk through everything on the slide here. There's a lot of details, but just at a high level, Wayfair uses Vertex AI to combine data engineering and data science and ML engineering workflows, enabling teams to choose a common tool set for collaboration and then to easily scale their workloads using the benefits of Google Cloud. And we've worked closely with Snorkel and Wayfair to ensure that as they develop new AI systems, that they integrate seamlessly with their existing workloads. Next slide, please. Wayfair is also capitalizing on Google's foundation models, including our newest and most capable set of models called Gemini. Many of you have probably heard of Gemini by now. It is built to be multimodal from the ground up. It's capable of sophisticated reasoning and advanced coding and lots of other things that you can do with it. But I could go on and on about Vertex and Gemini all day, but I think it would be more interesting to learn about how teams are actually using these systems, using Vertex and Gemini and Snorkel to build real business value. And with that in mind, Vinny, before we dive into the technology aspects of today's discussion, maybe you could walk us through some of the context of Wayfair's business and what's involved in helping customers to discover and purchase products that they love on your website.
Yeah, absolutely, Kiran. Thanks for that intro. I think that background context on Wayfair is really important, and Wayfair really sells everything for your home, ranging from spatulas to faucets to beds and couches. But a key differentiator for our customers is the massive product selection that we carry in every single category, because it allows them to find exactly what they're looking for. But in order to support that kind of massive selection, we've built out a platform that's really great at 2 things in particular. One is making it easy for suppliers to add new products so that we can actually maintain a compelling assortment. And 2 is making it easy for customers to actually find the product that they're looking for. Now, a key piece to both of those requirements is the challenge that we're going to focus on today, which is producing and maintaining a large amount of product metadata in a way that's low effort for suppliers, but exhaustive enough for our customers, and the algorithms that actually assist customers to quickly sift through that information in the catalog and find exactly the right product for their unique situation. Now, while that might sound similar to a bunch of other retail settings, there are a couple of things that make this product metadata that we store particularly impactful for enabling shopping in the home space. The first thing is that customers aren't often looking for a specific thing. They come here to browse. People come to our site with a high-level problem like, I need a new bed, or I want to refresh my patio for the summer. And they expect us to help them find the solution to that problem. They browse across multiple different categories over multiple sessions, over a week or more before making a purchase. And this is really different from a category like books or groceries where customers arrive to the site knowing exactly what they want, and they're just looking for a cheap and convenient way to get it. Additionally, customers want a really wide assortment of products and a really personalized experience. They don't want us to recommend the same bestseller that everyone that they know is already buying. They have really detailed and specific requirements, like trying to match an existing piece of furniture in their house. And customers don't really use supplier brands on Wayfair to really guide their purchasing in the same way that they might in a space like apparel, for example. This means that they start from a much larger consideration set, and they don't use brand as an indicator for quality and value. They rely on us, Wayfair, to help them make that comparison and arrive at the right trade-off for them. And we're often really talking about heavy and bulky items that are needed at a particular time. These things aren't easy to return. You can't just take your couch that got delivered and leave it outside for the mailman. And if your kitchen sink needs to be exchanged, it can delay your entire remodel. We rely on really detailed and accurate product information to make sure that customers are going to receive exactly what they expect. Now, let's dive a little bit deeper into the specifics about how we're solving some of these problems with the help of both Google and Snorkel. Now, bearing in mind that what I just said is we have customers that are coming to site with more of a problem to solve than a specific product to find, but they have those detailed requirements and a range of different tastes. How do we actually offer customers an on-site experience that's going to help them sift through that vast catalog to find exactly what they're looking for without that breadth of information becoming completely overwhelming? Well, we do that by personalizing the products that we actually surface to each customer throughout the entire on-site journey. We use information about their search and browse and purchase behavior to actually tailor what we show them next. And we also need a strong and furniture-specific semantic understanding of what customers mean when they search for things like retro or indigo. And lastly, we need to understand all of the different relationships between the products in our catalog. What are products that actually complement each other, and what products are good substitutes for one another if something's actually out of stock? And what's really interesting about this is that we really have to understand both our customers and the products that we're selling. We have to anticipate all of the information that our customers need to actually make the decision that they need, and understand our products well enough to know what differentiates them, how to compare them to one another, and what tricks can actually help us find incorrect data and then go fix it.
Thanks for that introduction, Vinny. Really quick, your conversations with Snorkel focused a lot around catalog tagging. Could you share a few more specifics about how all of that actually comes together?
Yeah, definitely. So let's talk a little bit about how we build up that product information. So we take in supplier data when they're actually uploading products to the website in various different modalities. So think things like images or structured and unstructured text information, and we process it through three primary steps. The first one is extracting product information through various multimodal models, as well as directly from the information that suppliers explicitly tell us. Then we validate that information. So we perform anomaly detection to make sure that the information across modalities actually aligns, making sure that the supplier didn't accidentally make a mistake when they're entering information like swapping the height for the depth of a product, or saying that their sofa only weighs 1 pound. And then we predict information that isn't given to us. So maybe it's information that's missing, or maybe it's something that's internal to Wayfair, like our class taxonomy, or something that we need to be really consistent about across the catalog, like color or style. And the data that we get from that process forms the backbone of metadata that is used to power all of the marketing content that brings customers to the website and on-site experiences too, like the filters we have on our browse pages and product information on product detail pages, and also keyword search. If you look at this picture on this slide, I think that you can see how that three-step extract, validate, and predict process would play out pretty naturally. We would extract all the information that we can get from the image and from the text that a supplier tells us about this product, and that gives us a subset of the information that you see here, like material and dimensions. And then in the validate step, we want to check to make sure that the image actually shows the square arms that the supplier's text input described, and that the dimensions and the weight are actually appropriate for this type of product. And then we would go ahead and predict additional tags like class, which is Wayfair specific, and style, which we need to ensure is consistently defined across all of the products in the catalog. Now, a key application of the product tags that we're generating here are search and browse filters. I've mentioned that a couple times already. These filters are customized to different product categories, and they can get extremely detailed. Customers are using these filters to restrict the products that we show them to the ones that actually meet their constraints. So think, how wide of a couch can they actually accommodate in their living room? Or what's the finish that they need on their bathroom faucet to match the lighting, for example? And about half of all of the orders on site actually come from these filtered sessions. Now, you can see in the example here that even with the filters of yellow and modern, we're returning over 1,000 different sofas. If you can't trust that we've only filtered out the products that don't meet your criteria as you add additional filters, then you would just become totally overwhelmed and you would probably abandon your search. Now, while we're looking at these couple of couches on this slide, I would ask you all to think about some of the poor online shopping experiences that maybe you've had. You might remember having low quality images or irrelevant images for some products, or duplicate products that are actually listed next to each other on a website with totally different prices, or product descriptions with bad grammar. And these types of problems reduce your confidence that you actually know that you're going to get what you think you're getting when the box arrives at your door. And you might tolerate some level of uncertainty when you just need new paper towels tomorrow, or you want cheap decorations for your 4th of July party, but you wouldn't tolerate that for a couch that you want to use for the next 10 years. So we rely on accurate, complete, and consistent product data to deliver that shopping experience that gives customers the confidence to actually go ahead and make a purchase. Now, historically, we've relied on supplier information, but that causes a lot of issues when creating the experience for customers that actually inspires trust. Now, remember that suppliers are incentivized to be generous with their tags, right? Suppliers want to remain on the browse page, even as customers are applying more and more filters. And I think the results that you see here really demonstrate the issue that this can cause. If, for example, if we just rely on the supplier's tags for things like image subject, then we would return the very first search result of cow wall art to actually be a turtle, which is obviously not great. But also, it's important to recognize that everyone makes mistakes and suppliers are no different, and we can't let those mistakes become our customers' problem. And ultimately, it creates this really unsustainable burden on suppliers to expect them to correct all of those issues. It would create a barrier for them to add new products to the existing catalog. And we can't just go out to all 20,000 suppliers and ask them to retag all 30 million or more products in the catalog when we want to know which of their products are relevant to a new emerging trend. And we just have to be better partners to think about how we can enable our suppliers at scale. Now, these two examples here are a bad customer experience, and customers can see that it's confidence eroding. And if they can't trust us to get something like geometric right on the pattern of their chair, then how do they know that the dining chair is actually sturdy when we say it is? But the worst ones are the undetectable issues that can actually result in customers being surprised by what arrives to their home. And that can be the end of their entire relationship of shopping with Wayfair. Now, the natural solution to this problem of maintaining and augmenting our product information at scale is machine learning, and that's exactly what we do. Remember that we have thousands of tags that we need to populate across millions of products on our website, but training data quickly becomes a constraint here because we can't actually rely on the labels from our suppliers.
Thanks, Vinny, for providing that context. And we know that Wayfair is always innovating, and innovation requires a lot of experimentation. I wonder if you could tell us about, some of the approaches that your team has taken and any lessons learned.
Yeah, definitely. Well, first we tried just using the supplier tags directly as training data, but that obviously did not work out because there are missing tag values and there's lots of inaccurate supplier tags. So we actually ended up with very few models that were accurate enough to actually use in an on-site fashion. And remember, like if we're going to replace information that a supplier has given us about their product, then we better be really sure that we're correct and we're right about that. So next, we tried using humans to actually annotate that training data. And this is accurate, but it's also incredibly expensive, and it can be incredibly slow to go and ramp up teams to go understand the problem that we're trying to generate labels for, and then annotate that data. And additionally, the interfaces that you can use can actually differ, and the options for selection differ on a per tag and a per category basis. And that makes it really challenging to perform this type of work at scale. And then third, we actually tried using open source models zero shot to predict the tags without needing any sort of specialized training data. And you can see that this actually does work pretty well in some cases. You can see that for wall art subject, it works pretty well. We can tag which pieces of wall art contain squirrels really effectively. But wall art, that's only 5% of our catalog. It breaks down. It doesn't really work well for more specialized tags like style or class. Clip, the model that we were using here, is just not good at distinguishing things like geometric from chevron. It's very nuanced and Wayfair specific. And so this is when we decided to start partnering with Snorkel. And there were a few factors that led to us wanting to partner with Snorkel specifically. Now, Wayfair is a data-driven company, so Snorkel's focus on data-centric AI really resonated with us. And if you think about it, ultimately, the reason that our models weren't performing really came down to the quality of our data. And Snorkel's approach to programmatic labeling would enable us to get higher quality data faster, plus be able to rapidly adapt to new styles and new products coming into the catalog. Next up was Snorkel's research credibility. Snorkel has really strong ties to Stanford and other academic institutions, and Snorkel researchers are collaborating on cutting-edge techniques on papers that haven't even been published yet. So partnering with Snorkel gives us access to top data scientists and researchers and the ability to capitalize on the latest techniques and ideas, not just technology. And they also have an incredibly strong Google partnership. Google's also a strategic partner for Wayfair, so we really appreciated Snorkel's partnership with Google. And Snorkel's integration with our existing Google-centric workflows really help us to build and deploy significantly higher performing AI services in days as opposed to weeks or months. And this means that when new trends emerge, that we can immediately refresh our catalog to reflect items that we already have that match that new style. And that's a true value unlock from a business point of view. Now, when we started working with Snorkel, we actually wanted to create and craft a thoughtful and pragmatic approach to our partnership, making sure that we were proving out Snorkel's capabilities on a really focused area that was high value and then expanding from there. So to start, we wanted to take something that exists today and make it better. So that was phase one, all focused on augmenting and improving our existing models for product tagging. Then we wanted to expand that capability across the entire Wayfair catalog and add another use case to really showcase the power of foundation models to generalize across the business. So we set out to build a model that speaks Wayfair's language in phase two. And then that leads us to phase three, which is where we really focus on taking those models and operationalizing them for deployment at scale. So let's dive a little bit into phase one, where we're leveraging Snorkel tooling for improving our product tagging models. We focused our attention on the 5 highest revenue classes in the Wayfair catalog, and we drilled in further to focus on product tags that power frequently used customer-facing filters that are on the site across those classes. And after exploration, we confirmed with Snorkel that the supplier labeled tags were really noisy and really sparse, and they actually didn't provide really useful results when training models. So we set out to fix that using the Snorkel Flow platform, and the results were really impactful. Now, the tags for the 5 categories in phase 1 yielded a data set of over 4 million images that needed to be properly labeled. And we partnered really closely with Snorkel here to prepare the data for the Snorkel iterative data development loop. Daniel, do you want to talk some more about what that Snorkel iterative data development loop actually looks like?
Absolutely, Vinny. I would love to explain what that means. So at a super high level, Snorkel believes that the most important ingredient in the machine learning landscape is your data, and data development should be synonymous to essentially software development. We've built a platform where you can define programmatic labeling functions, which enables SMEs and data scientists to simply efficiently apply expert reasoning over your entire data corpus, audit your intermediate results for errors, analyze problematic hotspots, and then root cause why they happened. So, for example, was it because I had incorrect labels in my ground truth data set? Was it because my label taxonomy wasn't sufficiently representative? Do I need to add another class? Did I construct and overfit my programmatic labeling functions? Or maybe the programmatic heuristics that I originally constructed actually conflict with ground truth. So I can use this as an opportunity to update my understanding of the problem. Step 3, quickly adapt and update your labeling functions for another round of data development. Do that for a couple iterations, and then finally profit. So the $1 million question, does the iterative data development loop actually work? Absolutely. The proof is in the pudding. Like Vinny mentioned, we chose to focus our efforts on 46 tags across 5 classes, which ended up to be about a data set of 4.2 million images. We then worked to clean, prepare, and dedupe the text caption and product SKU data for this Snorkel iterative data loop. As a quick heads up, if you don't clean your data, garbage in, garbage out. And a quick shout out to Kiran. We leveraged Google Palm 2 for this because Gemini wasn't available at the time. But even with Palm, we were able to successfully generate meaningful results. So after the data development loop, the results were staggering. We achieved a macro F1 improvement of 28 points, which is incredible. And we delivered this in just months instead of years as was originally anticipated with the traditional high human in the loop approach, which is about a 10x improvement in speed. The kicker, as a result of this partnership, Wayfair now has the ability to efficiently update and tailor tags as trends and seasons evolve, which is a really big game changer because consumer preferences are super fickle year over year. Vinny, that's all for me on data development. Back to you.
Awesome. Thanks, Daniel. And so these results are fantastic, but let's think about what does that actually mean for a customer that's shopping for a new floral accent chair. Now, by improving the product tagging experience, we're able to actually improve the overall customer experience by enabling customers to easily discover and purchase the items that they love within the Wayfair catalog. And that makes the overall Wayfair experience that much more pleasant, which is a win for all of us. So after this initial win, we started to actually plan out, well, what's the next leg in our journey? And that's phase 2, meaning let's take what we've done so far and go bigger. Phase 2 was focused on expanding the capability that we developed in phase 1 to the entire Wayfair catalog and showcasing how we can leverage foundation models to generalize to more types of problems across the business. So we set out to build a model that speaks Wayfair's language. But what does that mean? Well, let's talk about a specific problem, exact matching in the Wayfair catalog, where 2 identical products should be listed as a single product, but that's not always the case, and that creates duplicates on the website. If we look at some of the examples here, the first one on the left is an example where we have the same product on the same background, and these are really softballs and easy duplicates to detect on the website because it's essentially the same image. The second example is the same product with different backgrounds. Maybe there's a few more products added in the environmental image on the left, but these should still be matched together as one product. And it's getting a little bit more challenging than the first example. And then in the third example, we have a different product, but everything else in the image is actually identical. These need to actually be treated as 2 separate products in the catalog, and the model needs to be able to discern between those 2 different bookshelves, even though the background environment is literally identical. So our task in this phase is to build out a Wayfair-specific foundation model to handle that type of nuance. Now, Wayfair has a really specific taxonomy that's used to actually describe the products that are in our catalog. And a generic model, even a really powerful foundation model that's trained on general information from the web, may only be able to refer to this sofa on the left as something like a beige couch or use other common terminology that's very generic. But for Wayfair to deliver the customer experience that we aim for, we have to store much more detailed and category-specific information like the Chesterfield style of this sofa or the nail head trim that's on the arms of the couch, like on the example on the right. So working through the product tagging problems in phase one actually helps us to build out a model that speaks Wayfair's language and in turn ensures that when that massive couch arrives at your front door, that it's exactly what you expected. So now that we know what speaking Wayfair's language means, let's talk some more about that exact matching problem. And remember that what we're trying to do here is to take a given image and then find exact matches of that product amongst all other images within the catalog here at Wayfair. Now, the first column on this slide on the left is the image that we're actually feeding into two different models. The second column is the matched image that was returned by a state-of-the-art foundation model trained on widely available internet data. And then the third column is the match that's returned by the Wayfair foundation model. Now, the first case here shows a small accent chair that's in the corner of that first image. And then there are a couple other products in that image as well. The out-of-the-box foundation model got a similarly styled couch, but that's actually not the accent chair that we were looking for. So this would actually count as a failure for finding an exact match. The Wayfair foundation model was actually able to discern that the exact product what we're looking for is, even though the initial image only had a partial representation of that product, and the product was at a completely different angle from the matched image. And there are many other different products that are existing within that initial image. Now, case two shows a similar scenario here, but the important thing is that the shading or color of that area rug is actually going to change based on the angle that the photo was taken. And the model is able to actually differentiate that and find the correct exact match. How does it do that? Well, two really big reasons are, one, we're leveraging really high quality data sets. And two, we're leveraging really powerful foundation model architectures. So let's chat a little bit around how we actually curate some of those high quality data sets. Now, we invested quite a bit of time with our counterparts at Snorkel in building up high quality data curation. And these are a couple of examples just to highlight what kinds of problems we actually encountered and how we solved them. The first one was programmatic cleaning. So we had to clean the data and find entries that were actually ones that made sense to use to train a model. And the example here shows an image that's actually a picture of a placeholder image for no image available. And there were plenty of other issues that we had to address, like working with different image formats or different image resolutions or dealing with duplicate images in the catalog. Another example was programmatic sampling. So we're working with a really diverse data set with some classes that might have millions of images, while other classes might only have tens of thousands. And when working on building out that Wayfair foundation model, we needed to ensure that it worked across all classes equally. So we implemented a couple of techniques to boost rare classes while maintaining the performance on common classes. And let's be honest here, like, did everything work the first time around? Absolutely not, right? This required a ton of failed experiments and creative solutions amongst the team here at Wayfair and the research team at Snorkel. And this is just scratching the surface here in terms of the work that was actually put in to create this foundation model. So let's chat a little bit around the results for exact matching. And just a little bit of recap here to orient you. Remember that the Wayfair foundation model is built across the entire data set, and it's currently set out to solve two major use cases. One is product tagging, and the second one is exact matching. And a little bit of context here is there was a purpose-built state-of-the-art model that was built in-house here at Wayfair, whose only function was to do exact matching. And when looking at the exact matching problem, that's the model that we use to treat as a baseline. And we were able to beat that model over 98% of the time with an average increase of 14 points in recall at 1. So we were able to actually close out this phase of the project, which leads us to the present day today. and phase 3 of our project and work with Snorkel and Google to actually operationalize and deploy these models. So what we've done here is we've actually implemented a tiered strategy with multiple modeling approaches to support the complexity of the data that's created in a Wayfair environment. So first, we prioritize using Gemini for images where there's a really well understood taxonomy by models that are trained on these massive internet scale data sets. We don't need to build custom models to tell us the color of an object or the shape of a rug, thanks to models like Gemini. And next, we leverage the Wayfair Foundation model for images that need to align more closely with the terminology that's required to build out those high-quality customer interfaces that our users expect to see on site. And then finally, we can leverage things like Snorkel Flow to make sure our catalog stays up to date with emerging trends. Biophilic design is the example here, and that's a newer design aesthetic that's intended to connect nature to your space. And now we actually have a concrete mechanism to quickly update our taxonomy and have on-site experiences that meet the needs for emerging trends, like going ahead and creating a biophilic filter on our browse pages for customers.
And Vinny, it's really impressive to see how your teams are harnessing the power of different models and techniques here. And one of the areas that we've had a number of conversations on involves how to ensure Wayfair can operationalize this approach and to manage these models at scale. Can you talk a bit more about that, maybe?
Yeah, definitely. So the imagery and product metadata for all of our models and how it's consumed is all accessed via Google BigQuery and Kafka streams. So our catalog, remember, it's changing every single day, and it's important that we have a platform that's aware and responsive to those types of changes. And we've heavily leaned into the use of Vertex pipelines for everything from pre-processing and model inference to post-processing and model monitoring. But we've also invested in building reusable components to make sure that making and building new pipelines becomes easier and easier for the scientists and engineers on our team. And we output the data from our models in a very similar way to how we consume it. Again, leveraging both BigQuery and Kafka to make sure that downstream teams can easily consume all of the data that we're creating. Now, the primary objective here, when we're thinking about operationalizing this system, has always been to make sure that we're building something that can easily adapt to changes over time. And now we have a system that not only lets us deploy a model to a Vertex AI endpoint and monitor its performance over time, but now with the help of both Google and Snorkel, we can rapidly evolve the types of metadata that we can actually produce. We can create accurate labels for those new types of metadata that we've defined. And then we can even go ahead and retrain our own models with those data sets and begin that deployment loop all over again. So what is the bottom line here? Let's take a step back for a minute and think about what does this all mean and how has it actually made a difference for Wayfair customers? Overall, the results have been really, truly transformative. We've observed improvements across a variety of metrics. They range from product interactions and bounce rates all the way to more lower funnel metrics like conversion and add to cart rate. And we've even begun to see longer term metrics tick up like repeat rate and a dip in return rates. But what's really exciting about this work is that it's not just using generative AI for Gen AI's sake. It's actually having a real top line revenue impact. And it's impacting metrics that go all the way up to the board of directors and are incredibly important to Wayfair overall. So what are the key takeaways here? Well, in order to build these world-class customer experiences, we need to leverage machine learning to create really high-quality product tags across our catalog of over 30 million products. And training those models is really challenging, especially when using off-the-shelf foundation models doesn't really meet our requirements, and collecting the data to train our own models is incredibly time-consuming and expensive with human annotators. And so instead, we were able to work really closely with Google and Snorkel to create customized data sets that we could use to address multiple problems at once, including the tagging and duplicate detection work streams with a single Wayfair Foundation model. And thanks to our close partnerships, we've been able to create this tiered tag extraction pipeline to drive real, tangible value across a range of different input data complexities. So that's it for me. I'll pass it back to you, Daniel.
Thanks so much for your deep dive, Vinny. Really appreciate your effort explaining, Wayfair's product catalog use case in great detail. And thank you, Kiran, for talking through how Wayfair leverages Google Vertex AI for MLOps and Gemini for access to the latest, mostly modal foundation models. Before we break for everyone in the audience, if you'd like to learn more, we have a case study on the Snorkel website linked here that goes over the Wayfair and Google design partnership in greater detail. So if you need some written documentation, we have that for you. Check out our landing page for the new computer vision product that we're launching in 2024, where we talk about technical solutions, both for the retail product tagging use case that we went over today, as well as for satellite imagery, which we didn't go over in detail today. If you're interested, please schedule a demo with Snorkel Flow Computer Vision. Our account and services team would love to see how Snorkel can solve for your use case.